Hello, geometry. I'm out not feeling the best today, so I decided to just stay home and rest. I should be back tomorrow, hopefully. So what we're gonna do today, I know some of you maybe want some work time to get yesterday's assignment done. What I'm going to do is have you do these notes first, and then you'll have work time where you can work on this section assignment and then yesterday's assignment as well. We're going to be going into 3-3 today. So this is on page 6 and 7 in your note packet. If you don't have a note packet, there are a couple extras in the front table. Go and grab one. We're going into 3-3 just because it's a little easier to explain it over a video. Rotations, I kind of want to be there to help do it in person with tracing paper. So we're just going to do 3-3 because it is a little bit easier for me to explain being gone. So, translations are what we are looking at, and the definition of a translation. It says a translation slides an object a fixed distance in a given direction. When working in the plane, this is going to be represented by a vector, which comes across as an arrow. So you can see over here this little arrow, that's a vector. And what the vector does is it represents distance and direction. So it's telling you not only how far the shape should move, but in what direction it should move. A vector is used to describe the fixed distance and the given direction, and is often denoted by this sort of little carrot looking thing, x comma y. It will have two numbers there, and what it is it's telling you, if you look, the x value describes the effect on the x coordinates, right or left, and the y value describes the effect of the y coordinates, up and down. So if it's right, it's going to be positive. If it's left, it's negative. If it's up, it's positive. If it's down, it's negative. Similar to the reflection yesterday, there's a special notation, and with a translation, it's a capital T. So that capital T stands for a translation. This x and y, the x, that is telling you your distance moved. It's giving you essentially your vector. Okay, so your translation, x comma y, in that vector notation, it's telling you your distance moved, your vector. If you go and look at this picture over here, we see two different things being moved, triangle ABC and then line segment AB. They're being moved by a vector. We see that as the arrow. Down here, there are two things that show up as properties. If you look, it says AA prime equals BB prime. So that's why you'll see over here that these two dotted line segments that connect A to A prime and B to B prime are congruent. That just tells us that points A and B both moved the same distance. If you remember yesterday when we had reflections, the points didn't all move the same distance. Instead, it was dependent on how close or far away they were from the line of reflection. Number 2, it says AA prime is parallel to BB prime, and so it says it's a fixed directions. So segments are parallel. Those segments that are shown here with the two little arrows, those segments are parallel because A and B moved in the same direction. So they went in the exact same direction, same distance, and so you get congruent segments there, and you get parallel segments if you connect the pre-image to the image point. Okay, some characteristics. Again, I said we're going to fill in this chart for every transformation we cover. So the distances, remember this is talking about the distance the points move. So every point is going to move the same distance. So instead of being different, again, reflections, it was different because depending on Depending on how close it was to the line of reflection, that decided how far it moved. With the translation, you don't have that. Every single point is going to move the same distance. So every pre-image point moves the same distance. The orientation, the order of the points. The orientation will stay the same here. The points go in the same order. So if you go back up here, again, we're looking in, say, a counterclockwise direction. If we start at A, it goes A to C to B. In the second one, if we go in a counterclockwise direction, we start at A prime, we go to C prime, we go to B prime. The order of the letters ACB is still the same. That's what it means by that orientation. So points go in the same order. Special points, if you remember to reflections yesterday, are only special points where the points that were on the line of reflection did not move. With a translation, we have no special points. All points are going to move. Okay. So now it says describing translations and vectors. Again, I've said a couple times already, the paragraph up above, it says that a vector will describe a fixed distance and direction. It hits both distance and direction. So this arrow drawn in here, you will see that the distance it gives you is 5. We don't really need to find that. It's just relating this back to that distance formula, Pythagorean theorem type thing. To find that distance, we're taking 3 squared plus 4 squared, and then we're solving to see what we would get. Okay, again, you don't really need to know that. That 5 is just telling you a distance. Instead, what's going to help us are these numbers here, because this actually tells us how our x changes and how our y's change. So we talked about coordinate rules yesterday and how they describe what type of transformation the point goes through. So you'll see that the coordinate rule that describes this vector is you take the point xy and it goes to x plus 3 comma y plus 4. That's coming from these two right here, that to go from this point up to this vector point, you go right 3, up 4. So x plus 3, y plus 4, because we went, again, right 3, and we went up 4. The vector notation, if you look at it, the only difference is that we write it in that little vector right there. So it said 3 and 4. That still relates to the plus 3 and the plus 4. Okay, we're going to find the coordinate rules for these other vectors. So the first one here, we're going, say, from this point to this point, and they already show in there that we went right 4, and we went down 1. So if we're going to write our coordinate rule, put the t, x, comma, y, draw this little arrow to show that a transformation is taking place. What it becomes, we went right 4, so we say x plus 4, and we went down 1, so we say y minus 1. Down 1 is minus 1. The vector notation, basically just those numbers that you put in there go in the little vector notation. Again, it's x plus 4, y minus 1. They mean the same thing. Sometimes it will give you a plain coordinate rule. Sometimes it will just give you this part right here, the vector notation part, and you have to figure out what that means. Okay, our next one, we're going from, it looks like here to here. And so they show that we went left 2 and we went up 1. So if you're filling out that coordinate rule, our x changed by 2, subtracted by 2, our y changed by 1 because we went up 1, left 2. Our vector, we have a -2, and we have a 1. And so that is x minus 2, y plus 1. And our last one here, to go from here to here, we went left 2 and we went down 2. And it's already drawn out for us. So we're going x minus 2 and we're going y minus 2. As vector notation, that's a -2 minus 2. And it looks like that. Okay. So again, that vector is giving you a distance and a direction. Follow the arrow. That tells you sort of where you should be ending up with, and start. So the arrow kind of shows you where you should end up at with the vector. And like I said, these pictures gave you the numbers. Sometimes you might be given the vector and you have to figure out what those numbers are. But again, it's similar to when we found the distance formula and we just found the distance of those sides there. Pretty much the same thing, but you have to factor in direction as well. So that's how you're getting the positive and negatives. Okay. If you turn to page 7, here's where we're just going to go through a few more things. So the first ones are actually performing translations. And so the first one, it gives us a translation. It says the vector is 2, -3. That 2, remember, means x plus 2, which means we're going to be going right 2. This -3 is saying y minus 3. It means that we're going down 3. So what you're going to do is take every point in that triangle, JKH, and you're going to move them right 2 and down 3. So K, if I start there, K, I'm going right 2, down 1, 2, 3. And I get K is right here. H, I'm going right 2, 1, 2, 3, down 3. J, I'm going down 1, 2, 3. Oops, okay, going down 3 and I'm going right 2. So start at J here. I think I just said that wrong, sorry. Starting at J and I'm going right 2 and I'm going down 3. 1, 2, 3. So you end up with that right there. Okay, there's my shape. The next one, again, it's telling you have a translation with a 6, 0. So the 6, that's your change in x. So you're adding 6. The 0 is saying that your y value is not changing. If it's x plus 6, that means you're going right 6. If it's y plus 0, you're going up or down 0. So all of those all of those points, E, F, and G, they're going to just go right 6. So if I start with F, 1, 2, 3, 4, 5, 6. Here's where F prime ends up. G, 1, 2, 3, 4, 5, 6. There's G prime. E prime, 1, 2, 3, 4, 5, 6. E prime ends up right there. Okay? The last one, it says we're going to translate triangle LMN by the vector -3, -1. Remember that is x minus 3. It's telling you you're going to go left 3. This is y minus 1. It tells you you're going to go down 1. If we do that with all of those points, left 3, 1, 2, 3, down 1. Here's M prime. L, we're going left 3, 1, 2, 3, down 1. L prime. N, we're going left 3, 1, 2, 3, down 1. and we connect those new points. And again, fill it in if you want, you don't have to. Okay, so that translation, it's telling you how you are going to move that shape. Okay, the last part is all about using coordinate rules and sort of how they relate. So it says determine the translation rule from the given pre-image and the image point. So it says if I give you a pre-image and I give you an image point, how can I write the coordinate rule? So what you want to do is look at your ordered pairs. For my x's, I went from a -4 to a -1. So how did I do that? I added 3. That tells me that my coordinate rule is going to be taking the x value and I'm going to add 3 to it. If I do the same thing with the y's, to go from y of 1 to a y of 3, I would have added 2. So that means I'm taking y plus 2. How that looks like in vector form is you would have a 3 and you would have a 2. Okay, we'll go and do the same thing with this next one. So if I'm going from 7 to 3, so an x value of 7 to an x value of 3, I'm going to subtract 4. If I go from an a y value of 1 to a y value of 0, I'm going to subtract 1. So I say y minus 1. Over here in your vector notation, that means you're going to have a -4 and a -1. Okay, so this is strictly, can I figure out what the rule was? How did it change? It should always just be adding and subtracting when we're talking about a translation. So all we have to do is add or subtract numbers. Okay, last part, it's similar to this part we just finished with. You have a pre-image column and you have the image column. What it's going to give you is it's giving you the translation rule, it's giving you that coordinate rule here, and it says, can you find the image points then? Or the pre-image points. So the first one, it says that we have the point -1, 2. And what it says is that we take our x value, okay, the coordinate rule says we take x minus 6 and we take y minus 1. So you're going to put, for x, -1 minus 6. For y, you're putting 2, 2 minus 1. So -1 minus 6 gives you -7. 2 minus 1 gives you 1. You end up with an image point A prime at -7, 1. If you go on to the next one, again, we have an x minus 1 and a y plus 1. So we're going to take that 4 and subtract 1. We're going to take the 3 and we're going to add 1. 4 minus 1 is 3. 3 plus 1 is 4. Okay, the next one's kind of weird. It says our coordinate rule, x is going to stay the same. Y is going to subtract by 4. This time, we are not given a pre-image point. Instead, we're given the image. So what you're trying to find out, what x value remained unchanged and became 8? What y value was subtracted by 4 and became -5? So again, what x value was 8 and what y value subtracted 4 and got -5? Essentially what you can do, first of all, what x value would 8 have had to been? It would have had to have been 8 to start. If x stayed the same between the pre-image and the image, as this x right here tells us it did, it would have started as 8 because it ended as 8. What number was subtracted by 4 to get -5? If you set this up as an equation, y minus 4 equals -5, you're working backwards. What would I have had to start with that I would have subtracted 4 from to get me to -5? And I would have started with -1. Again, because if you take -1 minus 4, you're going to get that -5 that you were trying to find. Okay, the last three here give you vector notation. So remember, if it's -1, that means we're going x minus 1. If it's a -2, that means we're going y minus 2. So x minus 1, y minus 2. We're taking 9 minus 1, -5 minus 2. 9 minus 1 is 8. -5 minus 2 is -7. So 8, -7. 2 left here. The first one, x plus 5, and y. If that's at 0, that means y stays the same. And so if you're working backwards, to get this -1, you took some number x and you added 5. To get this -7, it would have been your y value to start because y didn't change. So what you have to find out is what number did you add 5 to get that -1. So subtract that 5, you would have gotten a -6 right there. Our last one, vector notation. So that 4 tells us x plus 4. The -3 says we took y minus 3. You have that ordered pair there. If we're taking x plus 4, y minus 3, we're taking 0 plus 4, -7 minus 3. 0 plus 4 is 4. -7 minus 3 is -10. So again, if you are trying to find the pre-image point, you're working backwards. You have to set up some sort of equation here or think backwards. How did I get here? If you are given the pre-image and you need to find the image, just use the coordinate rule they gave you to find the missing image point. Okay, so here's our last one. A translation of xy to x minus 3, y plus 5, followed by a translation of x minus 7, y minus 1, would result in a single translation of all points. What would that translation be? So basically it says if you do two translations in a row, you could rewrite it as just one translation. So think of it this way, x minus 3. That means we're going left 3, and then x minus 7, we're going left 7. So total, how far are you going left? We're going left 10. If we go do the same thing here, y plus 5, we're going up 5, y minus 1, we're going down 1. So your total for your y's, you go up 5 and then you go down 1. You still are up, but you're up only 4. And so this coordinate rule that you want to make, it takes point xy and it says x minus 10, y plus 4. You sort of just add them together and you get what you are looking for there. Okay. Okay, so that's all I have for you for your translation notes. What you have now for the rest of class is to not only work on your assignment for 3-3 that will be open on ALEKS, but also go back and make sure you finish 3-1, the reflections homework from yesterday. If you are done with both of those, your new topic goal should be open. Remember that this week you only have to do 4 topics. So if you want to do extras, now would be, this week would be a good week because if you do your normal 12, you're actually going to be getting 8 extras there. Okay, so have a good day. If you have questions, bring them tomorrow. But otherwise, look at your ALEKS examples. They're all really good there. Okay, so have a good day. I will hopefully see you guys tomorrow.